And yeah, so throughout this tutorial, feel free to interrupt me and ask any questions. Yeah, I don't know if I'll be going too quickly through stuff, so especially if you've never used CAD before, don't be afraid to ask me really basic questions. Um, and also, I'll keep an eye at the chat for those who don't have mics. And then I put in like a little PowerPoint that is in the announcements chat. So that's just what I have on my second screen that I'm following through to make sure I get through all the things I want to talk about. And then it would be a good idea to open up SolidWorks and just have that open. And as I'm talking about the different things you can do, you can try those yourself. And if you like run into a problem, you can just ask me and I'll try to figure it out. You could probably also screen share and I could take a look. And then at the end of this, I'll just go through CADing up a pretty basic part, and you guys can follow along. That way you can sort of try out the things that we're talking about. Phil and Raph, you guys have any luck?
It's recording the right screen. It's just, for me, the stream is just always loading. Like I don't see whatever your screen you're displaying.
Oh, is it?
I'm just working on trying to fix probably my internet issues so
Okay.
that I can actually watch it.
I
Because
hear you.
what are you showing right now?
It's just a web page right now, a blue web page.
Okay.
You may have to exit out of the stream and then open it again.
Mm-hmm.
Just closing the window. Okay, any luck with that?
No, for some reason it's not loading.
Okay. Oh, no one can see it? Okay, I'll try to set it up again. Okay, let me know if you guys can see it. Oh, it says every
Okay,
once
there
in
we
a
go.
while it says like we've paused this screen to save your resources. Let's see if I can ask it to stop doing that. Oh wait, it says pause the preview. Can you guys still see my screen? Like me moving this window around?
I can see.
You can?
I
Okay,
can
cool.
see.
Awesome. Okay, it's just hiding the preview from me, but that's fine. Okay, cool. Alright, so I think I'll just start. Does anyone object to me starting? Okay, cool. So open up SolidWorks if you have it installed on your computer already, and you can follow along. So, I'm gonna go from like the very basics. I'm just gonna go over the little agenda that we're gonna go through. So I'm just gonna go through some pretty basic recommendations in general for SolidWorks and for using it for this year. I'm going to show you how to set up a part, how to use SolidWorks for the first time, like what settings to check and uncheck. I'm going to show you what sketches are and how to make them and use them, and then relations, which are really important. We'll get into that. Dimensioning, and then navigating in SolidWorks in 3D. It's similar to other 3D programs, but if you haven't done anything in 3D, it might be a little weird to get used to. And then features, so like extrusions and revolves and stuff. And then I'll make a little demo part, and then you guys can follow along. Oops. Oh, I'm gonna open SolidWorks again because I want it to be the same window that you guys get at first. Who in the stream has SolidWorks ready to go? I'm just curious.
I do.
Mine's- Yeah, same. Mine's just opening now.
Okay, awesome. Okay, cool.
Same here.
Good, nice. Yeah, it should be good if you guys follow along. Just waiting for it to open. Okay, so when SolidWorks opens up for the first time, you get this window. And then what you're going to do if you want to start a part or an assembly, which we'll go over in another tutorial or drawing, you click this, which is new part, and you can also open parts that you already have on your computer. So we're going to click the new part, and then once you click that, it will create a new part. Surprise, surprise. Yeah, so I'm gonna walk through kind of the main parts of the SolidWorks UI. Can you guys see my mouse? Is it hard to see? Okay, I'm gonna assume
I can see it.
you can see it. Okay, awesome. Right. So when you open up SolidWorks, when you use SolidWorks in general, you should be using a mouse, not a trackpad. I've tried using SolidWorks with a trackpad and it's very annoying, so don't do that. And if you haven't already, you can go in the top right and there's a little question mark. And you click the drop down beside the question mark and then down to tutorials, and you can do a bunch of tutorials that SolidWorks has built in. I'm sure a lot of the stuff that I'm going to talk about will be covered in the first few tutorials in SolidWorks, but these are pretty comprehensive. You can learn the basics of everything through that. Also, if you don't know how to do something, the best way to figure it out is to Google it, or you can ask me or someone else on the team. And I like to watch just random YouTube videos of people making stuff in SolidWorks, and that usually helps figure out how to learn new techniques and stuff. So when you set up a part, the first thing you do, right, is you click new part, and then the next thing you're going to want to do is save it. So you're going to save it somewhere. I'll just create a new folder called tutorial 1. Put that in a better spot. So you save it, and you got to come up with a name that's good, right? It has to be thoughtful and explain what the part is. You can't just say like thingy number 52 because that'll just get confusing. In the slides, I've got kind of like a good naming convention. You can look at that if you want on your own time. It'll really only matter when you guys start submitting parts to put in the CSM. But for now, I'll just say like tutorial part number 1, and I'm gonna put my name. Usually you can just do first initial and then last name, and then I'm gonna do the date. So that way when I look at the list of all the parts I have, I know what I'm talking about. I know what I'm looking at. So now that we've saved it, we can actually start using SolidWorks. So the first time you open it up, I'm going to recommend that you go to the top left and click this little arrow. Once you click the arrow, you see you get like the file, edit, view, all those things. You're going to want to pin that so that way it's there always. That's just a good little tip. So the SolidWorks UI is split up into a bunch of different sections. Just making sure that I'm actually recording. Yeah, okay, cool. So it's split up into many sections. On the left side, you have what's called the Feature Manager Design Tree. So like Design Tree for short. If you hover over icons, you can see what they are. It says Feature Manager Design Tree. This is where your part is. So that first item is your part, and then under it is everything that's related to your part. So you can ignore the first 3. Material is an important one. And then you've got your 3 main planes, and then the origin of the part. And then once you start putting sketches and features in, those will also be shown here. Then you've got the property manager. That's the next tab over on the left. That lets you see the properties of parts and sketches. So if you click on a line, it'll show you how long it is. We'll get into that later. And then there is the task pane on the right. So this has things like a file explorer. I think it takes a second. It's got the design library, which is actually super useful. You click on Toolbox and click in Add In. You should all have it with your licenses. It's basically a big directory of parts that you can just import into your assemblies. So if you want to use a certain size bolt, you can just pull from there. I'm not going to go over that today because it's a little complicated, but you can look into that on your own time. And then the main region, get rid of this by doing something. Just clicking apparently. So this is the graphics area, the main area. That's where your sketches will appear and your part will be once you start drawing. At the top is what they call the heads-up view toolbar, kind of a weird name. But at the very last thing, there's view settings. You're going to want to make sure that perspective is unchecked. In engineering, you don't use perspective because it messes with the way, like it's perspective, right? So things that are quote unquote far away will be smaller. But when you're designing parts and when you're making drawings, you want everything to appear the same size, so that way you can see their relative size. So just make sure all these things are unchecked. You can ignore this. I always get issues when I change the scenery, so I suggest not touching that. And then in this icon, you can hide and unhide various things. You can show and unshow the primary planes. I usually have them hidden. Actually, let's leave them up. You can hide points, lines, axes, sketches, blah blah blah. You can look through that yourself. That's pretty useful if you want to just hide all the sketches really quickly if they're annoying you, which they usually annoy me. At the bottom right is very important. You're going to want to change your units. So at the bottom right, you're going to click the thing. It might be set on inch pound second or meter kilogram second. I'd suggest doing millimeter gram second or meter kilogram second. The meter kilogram second is really, it's the SI standard, so you should do that, but millimeters are kind of easier for the size of parts that we're working with. I'd avoid inch pound second. Yeah. Just gonna go to my next slide. Okay, so now we're gonna talk about sketches. Sketches, all these concepts are pretty much universal across various CAD programs. So once you learn this type of stuff here, you can basically apply it to any other program, like Inventor or Creo or all the other programs. So sketches are like 2D sketches, and they are created on a plane. So first you have to select a plane to draw a sketch. So you can do that by either clicking the plane before you start drawing, or clicking on it after. The way to unselect something is you hit escape, or you can just click in a blank area of the graphics area. So I usually click the plane first, and then I'll go in this little toolbar, and I'll click on the sketch toolbar, and you're gonna go up to sketch, and then you can see there's various options, but don't use 3D sketches, just use normal sketches. You're gonna click sketch, and since I already selected that plane, that's the plane that I'm going to be sketching. So if we close that, we can exit the sketch with this little button, and you can discard a sketch by clicking the X. I'm going to discard that, and then it's asking me if I want to keep my changes. I don't want to do that, so I'm just going to show you that I can also just click sketch and then click a plane after. So that's pretty simple. If anyone has any questions, let me know. So there's various types of sketch elements that you can use. I'm going to click at the top and hide the primary planes, so that way I have a clearer working area. So after the Smart Dimension tool, which we'll go into later, there's several different sketch elements. There's lines, circles, splines, which I don't like, rectangles. You can do arcs or portions of circles. You can do ellipses, slots, polygons. You can make fillets. And if you notice, all these have drop downs, so there's variants of all of them. In the line, you can do a line or a center line or a midpoint line. In the circle, usually what the drop down is a variant in the way it's created. So if you remember from like math classes, you define a circle, right, with a point and a radius. So that's this type. You can also define you can define a circle by defining 3 points. So you can use that function, which I never really use. It's kind of not really useful for what we do. So I'm just gonna click on the regular line. I can also just click on the box if it's already selected. If you notice, the feature, the property manager pops up on the left. You can mostly just ignore that for now. So I'm going to draw a line, right? And then if you notice, those yellow dotted lines are popping up, right? So I started drawing a line. I just hit escape to cancel. So I click on a line, right? And I click once, and that gives me my first point on the line. And now I can move my mouse and define where the second point is. So then I can click anywhere on the screen to tell it where the second point is. So the line tool actually lets you draw a continuous series of lines. So if I click again, I'll get another line. If I click again, I'll get another point that defines the end of the line. If I want to stop drawing lines, I can hit escape, and that'll stop that tool. I can click on a sketch element that I've drawn, and I can hit the delete key on my keyboard. I don't think backspace does not work. You have to hit the delete key. I think you can also right click and delete if you don't have a delete key. So I'm going to delete all those lines. You can do circles, right? So I clicked on the circle where it's defined by a point and then a point on the circumference. So you can also see in this window on the left that it tells me my first click is going to be my center point, my second click is going to be a point on the radius. Also, if you are trying to use these tools and you forget how to use them, or you don't even know how to use them, you can click on the little help icon, and it will tell you what everything means on the left. Hold on. Yeah, and you can also type in, you click on the help at the top right and you type in circle eventually. Yeah, so circles, you go to that, it'll tell you everything you need to know about using that specific element. So sketching circles, if you don't know how to do that, it says click on circle, click somewhere on your graphics window and that'll do the center point, and then click again and that'll tell you where the radius is. So I'm going to show that. You click for your first center point and then you click again and that gives you a point on your circumference. So if you notice, after you start making a feature, it's back to drawing another. So if I were to click again, I would get another circle with another center point and radius. So you can hit escape to stop making more circles. I'm going to delete those. And then you also have rectangles, which are pretty self-explanatory. You can see that I can define it with a corner. So I can define one corner and another corner. I can hit the drop down and do a center rectangle, so a center and then one of the corners. I can do 3-point rectangles, 3-point center. You can mess around with this and see what you like best. Some are useful for different applications. So I can click in the graphics area and drag, right? And if I go left to right, I'll select everything in that box that I just made. If I go right to left, it selects everything I touch. So if you noticed on the left rectangle, I am touching the top and the bottom lines. When I do that with a right to left selection, it selects the lines. If I do it with a left to right selection, a blue selection, it only selects things that are completely encapsulated. So it didn't select those top and bottom lines. That's a useful thing if you have a bunch of things to select. You can like avoid selecting certain elements. But in general, click and drag you can use to select multiple things and delete them. I'm going to put a couple lines and hit escape, and I want a line at a different starting point. That's why I hit escape. I can select multiple things by clicking on one of the lines, and I hold control and then click on something else. So now I've selected 2 lines. I can drag those around if I want. I can delete them. You can do Control Z to undo. I can also Control C to copy them. I can paste them, and I can have more lines. So I'm going to select all of them and get rid of them. There's a useful feature called the trim tool. I'm going to draw a circle, and then I'm going to draw a line. So first line point, second line point, and then I'm going to hit escape to stop drawing a line. So you go here, there's a tool called Trim Entities, and what that lets you do is draw a line, and anything that it touches, it'll delete that segment of the element. So if I draw a line, so I'm going to click and drag into this line, it will delete that. And if I do that here, it'll delete that. And if I try to delete the circle, it'll cut off part of the circle and give me a circle with a segment cut out. Or is it sector? I don't really know. Anyway, so that tool is very useful for making more complicated geometry than lines or circles. I selected all of them and hit delete to get rid of it. And if I draw something in my sketch, right, I can exit it at the top right by hitting this icon. If I hit the other icon, it deletes the whole sketch. So don't hit that unless you want it gone. So there's my sketch. We're going to talk about relations. These are very important. So now that I have my sketch, I want to go back to it and edit it. I could start a new one, but I want to edit it. So I'm going to go to my left side in the feature manager. What is it called? The design tree, sorry, my bad. So if you notice, this is my part, right? And in my design tree, I now have a sketch. The names of the sketches are created by default. You can right click on it and then click feature properties, and you can call it something else. So I call it first sketch. Doesn't really matter, but if you have a part with a lot of sketches, this can help you stay organized. So I'm going to right click on that and then hit edit sketch. That's the first icon. So I don't want this circle anymore. So relations are a really useful feature in SolidWorks. Instead of like, I'll just demonstrate. So if I draw a line, so first click, second click, escape, other line, first click, second click, escape. I have these 2 lines, and say I want them to be parallel. The way I do that is I'll click on one line and select the second one as well by control clicking on it. And if you notice up near my mouse, if you didn't move your mouse, you'll have all these icons pop up. They'll also appear on the left in the property manager. So if you see, there's things like horizontal, vertical, collinear, perpendicular, parallel, equal, fix. What all those things means is it'll look at the selected entities in this box here. So I clicked on the line and I control clicked, and I have 2 selected entities. It'll tell me what existing relations exist. I don't have any, so I can tell it to have some. I can tell it that these lines are parallel. right? So now these lines are forced to be parallel. I can get out of this window with this check mark. So no matter what I do with these lines, if I try to move this point, it'll force these lines to be parallel. So that's very useful. The little green icons are the relations. They're very small. If you zoom in or out, you can't actually get rid of them. Zooming is with the scroll wheel, by the way. So if I click on one of the relations, I can see it highlights in pink what's related to that relation. So this parallel icon tells me that these two pink lines are parallel. I can also I can select it and then hit delete and get rid of that relation. I can Control Z to get it back. I can click on the line once and it'll show me the properties. I can see what relations it has and I can delete it through there, which is useful. I'm going to delete those lines. So if I've got a line and I start it at the origin, if you notice there's a little yellow icon. That icon is the coincident icon. What that means is the point that I'm about to draw will be coincident with this orange that it's snapping to. So that means it's going to be coincident with the origin. Coincident means it's at the same geometric point in space. So if I click that, that first point is now coincident with the origin, and my second point, I can decide where to put it. If you notice, a yellow vertical line pops up and it kind of snaps me to the vertical position. And same with horizontal, I get a yellow horizontal one. What that's telling me is if I put down my point, yellow means it will create that relation. So if I were to just click, it will create that line, but if you see in green, green tells us what relations it has. It now has the horizontal relation. So remember when I did the first point, it gave us a yellow coincident icon, that little circle with the line sticking out. I'm sure you can't really see from the stream, so if you open up SolidWorks yourself, you can see that when you draw it. So since it gave me that yellow icon, yellow means it's about to give me a relation permanently. I have that that coincident one, and I have this horizontal one. So I'm going to delete that line, draw a similar line. Say I meant to do horizontal, hit escape, start drawing lines. I can click on that, and then on the left side, click horizontal, and that'll make it horizontal. If I wanted it to be vertical, I could click the existing relation, delete it, make it vertical. So these are very useful. Instead of like defining the angle is 90 degrees, you can just do horizontal and vertical. It's a lot faster. It's mostly faster because if you start drawing, SolidWorks will snap you to doing vertical or horizontal. Another quick thing is white colored relations. So if you see on my cursor, I'm about to draw the first point of a line, and I have this white horizontal line. So what that means, and you see the dashed line, that means it's going to make this first point horizontal with whatever's touching the dashed line. But white means it's temporary. So if I put that point down and then I put another point down, if you notice, there are no green relations. So that white one just told me that it'll put it there for when I'm starting to draw, but it won't actually make it permanent. So keep an eye out for white ones. See, it's trying to do the white one again. You can click on that point, click on this point by control clicking, and then make them horizontal if that's what you wanted. I'm going to undo, and if I didn't do that, notice that it doesn't actually stay there. So there's also a bunch of other relations, right? If I click, escape, click, I have these two lines. I can click one, control click the second, and I can make them equal. That one's really useful instead of defining dimensioning a length 2 times. You can do things with circles, right? If I draw this circle and I draw this line, I can click on the line, I can click on the circle, and I can tell them to be tangent, right? So if I move the circle around, it'll stay tangent to this line. Yeah. The next thing I'm going to talk about is dimensioning. This is very, very important. Relations are important, but they aren't required. Like, you can get away with not doing any relations, even though it's not the best practice. But dimensions are something you have to do in all of your parts. Oh, I'm actually going to mention one more relation that's useful. If I draw a line, and I start to draw another line, or any other thing for that matter, and I start moving near the center of the line, you'll see it will, you'll get this little symbol, and if I were to click on it when it's orange, like the symbol turns orange, I get a yellow midpoint relation icon. You'll start to learn what the icons are later, the more you use it. But if I click there, and it's yellow, which means it will be permanent after I've clicked it, instead of white, which would mean temporary. Now that point, and I'm going to click again, now that point is forced to be a midpoint on that line. That's a useful relation. Instead of defining like half of a distance, you can just use midpoints. So it doesn't matter how long this line will be. That point that I just created will be at the midpoint of that first line. Alright, so dimensioning. So the first dimension you make in a sketch in a part, like the very first dimension you make, will define the scale of the whole sketch. So if I were to make a line, first click, second click, escape to stop drawing. I hit Smart Dimension, this is your dimensioning tool, and I click on this line. Now I can draw, I can define the length of this line. So if you notice, if I move the cursor around, it can snap to telling me, or to dimensioning the horizontal distance. It can snap to doing the vertical distance, or if you kind of hold it kind of normal to that line, you can do the overall length. So if I left click, now I engage that dimension, and you don't have to click anything, you can just start typing a number. That first box is the name, I'd say don't touch that. The second box is the distance. So once you click that first time, you can just start typing. So I'm going to say that I'm going to make this 50 millimeters. My units are millimeters by default, but SolidWorks is pretty cool. You can actually type inches, or mm, or meters. Doesn't matter what you do, you can type your units into this box, and it'll automatically convert it to the units of the part. So if I typed 50 meters, it would convert that into 50,000 millimeters, unless I did my math wrong somehow. You can also put expressions, right? So if I want to do like 50 divided by 3, I can literally just type 50 divided by 3, hit enter, and now it made that 16.6 repeating, which happens to be 15 divided by 3. If you notice, the line didn't change length. So the first dimension you make in your sketch, the first dimension you make in your part, really, will set the scale. So I made that 16. If I double click it, this is, now you're able to edit the dimension, and I put in 50, it won't rescale, it'll just get longer. So you'd have to start a new part to reset the scale. So that's why it's important to it's important to know that it'll set the scale of your whole drawing. Yeah, so I've made this dimension. The dimension tool is still open, so now whatever I click, it'll try to start making dimensions again. If I hit escape, I can stop dimensioning. So I'm just going to show that again. So I'm going to make this line, click, click. I want to say that this line is 30 millimeters, so I click Smart Dimension, I click on the line, and then I move the cursor out to make sure that it's doing this dimension, not the vertical or horizontal. So I click once with the left mouse button. I can immediately start typing 30 for 30. I don't have to type millimeters because that's the default already. and I can hit enter on my keyboard, or I can hit the check mark icon. So, yep. Now it's still dimensioning, so I'm going to hit escape because I don't want to dimension anymore. So the dimension tool can make length dimensions, and it can also do angles. So I'm going to click on this dimension. It's kind of tricky. You can't click on the number because it'll start to edit it. If you double click, it opens that window again. If you single click, it'll just edit the number. You're going to want to click on the lines of the dimension. You can't click on the number. Click on the line of the dimension. Left click it once, and you hit delete. That's how you get rid of it. I just undid that, and I can also right click on the lines of the dimension and delete it. So that's kind of a tricky thing you have to get used to. I'm going to make a second line. If you notice, now a yellow icon is popping up. That's telling me whatever first point I set for this new line will be concentric with this point. So it's basically telling me the two endpoints of these lines will be the same point. So I'm just going to draw a couple lines. If you notice, it'll snap me vertical, which is useful. But it was a yellow icon, so it means it's permanent. So there you go. Again, click the Smart Dimension tool. So you can click on a line, or you can click 2 points. So I can click 1 point and control click the next point. That'll do the same idea. So instead of defining the length of the line, I'm defining the length between these 2 points, which is really the same thing. So we made that 30 previously, but since we deleted it, we'll have to make it 30 again. I'm going to click this point and then control click this point. That lets me do this dimension. I'm going to make that 35. So now I can click. So now I want to do an angle. The way you do that is you click on 2 lines, or you click on 3 points. So I'll show you 2 lines. Click this line, control click this line. So now I can do that angle, then left click, and then define that, let's say 45. I'm going to undo that, control Z, undo again. I can also do that with 3 points. So I'm going to click this, control click that, control click this, and now you see it's being kind of funky, right? It's trying to do this angle. Not sure why it did that. Interesting. Anyway, the dimension tool is weird. I haven't used SolidWorks in like a year and a half, so don't be mad. But in general, when you're doing angles, it'll be between 2 lines, so you just click the 2 lines. You can also do this angle, it'll snap to that. You can do this external angle. And then the last thing I'm going to show is you don't have to say that this angle is 90. I can just click on one of them, control click on the next one, select both of them, and I can just give it the perpendicular relation, which is a useful one to do. So if you notice, I wanted that to be 35, so I'm going to double click it, 35. If you notice, all of these lines are blue. Does anyone in the stream know what blue means? Like for those who have used SolidWorks before? Okay, I'm going to assume no one's familiar. So that blue means that it's underdefined. So underdefined, fully defined, and overdefined are very important concepts in engineering in general. I'm going to delete all these and start with a simpler example. So I'm going to do a line by telling it 2 points. So this line, it's not at a fixed spot, right? I can move these points and they'll be anywhere. If I gave this drawing, like if I gave someone a drawing of this line and I told them to draw it, like paint this line on a piece of paper, they could just do any straight line and that would technically be correct, right? So if you kind of extrapolate that analogy, if you give someone a part and you don't say what the dimensions are, they can give you anything that looks similar to what you drew, but they can do whatever size they want. I'm going to show you how to define lines. So blue means that it's underdefined. It means that I can, in SolidWorks, you can check by just dragging it around. I'm going to take this point, click it, and then control click with the origin. I'm going to do coincident. So now that is forced to be on the origin. I'm going to take a drink of water. So if we look at this, it's still underdefined. We can tell that by it being blue. You can also see it in the design tree with this little minus icon. And we can double check that by moving this point, and we notice that it can move around freely. So this point has 2 degrees of freedom where it can move X and Y, so I'm going to fix it in place by giving it a horizontal dimension. So I'm going to click the smart dimension, I'm going to click the first point, and then control click the second point. Actually, do you even need to control click? No, you don't. Fun fact. I don't know, it's good practice in general to be comfortable with. If you want to select multiple things, you hold control. I'm going to give it a horizontal dimension of 20 millimeters, and then I'm going to give it, so if you notice, it's still underdefined. It doesn't know where it is in the Y direction, in the vertical direction. So I'm going to give it another dimension of 40, and if you notice, now all of the sketch elements are black. I can't drag anything around, and there's no minus icon. So now if I gave this to someone and told them to paint it for me, right, they would have to draw a straight line that's 20 millimeters in its horizontal direction and 40 in the Y. So I'll show you that. Oops. Yeah, I'll delete it. So it asked me if I wanted to delete it because it had dimensions associated with it, right? So I gave it that 20 and the 40 dimension. So it was just checking to make sure I wanted to delete it. I'm going to draw this circle, and I'm going to, if you notice, I'm free to move it around, and I'm also free to change its size. So I'm going to give it an X position of 10, a Y position of 30, and then I'm going to give it a diameter. So in general, a circle, you don't in engineering talk in radii, you talk in diameters. Because if you think about it, if I have any circular object, let's say like I have a marker and I want to know like how big it is, there is no real physical way to measure the radius of the marker, right? You have to somehow make sure that you know the middle point precisely, but the marker is not perfectly round, so how are you going to find the middle? Anyway, so what you do is you talk in diameters. That's why in SolidWorks it defaults to giving you diameter. So what I did, I'm going to hit escape. I clicked Smart Dimension, I clicked on the circle, and that'll start my diameter. So I'm going to make that 40 millimeters in diameter. So because I gave it the center point, an X and a Y position, and I gave the circle a diameter, it's fully defined. So whenever you make a sketch, you want to make sure that it's fully defined, so there's no minus sign. Everything's in black, because one, you can't physically make something unless you give the person all the dimensions that are required, and two, you may design something, right? Like if I make this triangle, I let it do that automatic horizontal. I want to make this like an isosceles triangle, so I'm going to click on that midpoint at the bottom, control click at the top, and click at the top, control click that midpoint, and I'm going to, why is it bullying me? There we go. I'm going to click vertical, so now isosceles. So say I made that, right? And this is my sketch, and who cares about the circle? This is my sketch, right? And if I exit out of this and use this somewhere, right, sure it has the right dimensions now, but what's saying that someone doesn't accidentally open this sketch and scoot that over, right? So you need to fully define everything, otherwise, one, you can't build the part, and two, you could accidentally change it in a way that you can't really keep track of. Just going through this little slide I made to make sure I covered everything. Yeah, so that's the basics of dimensioning. Delete that. I'm just gonna close the sketch and we'll do a new sketch. Oh, well that's back. That's fine. So next I'm gonna talk about navigating in 3D in SolidWorks. So if you haven't used a CAD program, this might be weird. I'm going to turn on the primary planes using that heads up view icon thing. So if I hold the middle mouse button down and then I move my mouse while that's selected, I can orbit, is what it's called in CAD programs. So holding middle mouse button and dragging the mouse makes me able to rotate everything that is in my CAD part. I'm pretty sure this rotation, it happens, yeah, I haven't used SolidWorks in a while, so I don't actually know what it's rotating about. It doesn't look like it, yeah, it's not doing the origin. Anyway, so middle mouse button, click and hold, and drag is to orbit. If you want to pan around in your part, you're going to hold Control and then middle mouse button drag. So you can move things around. You can orbit. So nice and simple. And then you can use the scroll wheel in and out to zoom. It zooms toward your cursor. So if I zoom like this, it'll go there. If I zoom like this, it'll go here. So once you start using SolidWorks a bunch, you're able to use all these things in tandem and move around pretty quickly and orient the part the way you want it to. But sometimes you can't line it up perfectly, or you get confused and you don't know what you're looking at. And the way to deal with that in SolidWorks, which is really nice, is you hit the spacebar, and it opens up this little orientation cube type thing. And if you click on the face of this cube structure, or these floating faces, it will orient you in that direction. So that was kind of fast. If I click this corner, for example, it'll rotate it to let me see from that direction. It'll make more sense once we have a an actual 3D part to look at. You can also orbit while looking at this cube by control or middle mouse button clicking and dragging. And that can help you orient yourself. You also notice that this this dialog comes up the top left, gives you your front, bottom, right, all your views. You can click on this drop down and look at your part in an isometric, dimetric, or trimetric orientation. I'm not going to explain what those mean. I think you learn about it in first year at some point. I love looking at parts in dimetric. Isometric is a little confusing sometimes, but dimetric helps you kind of get a feel for all the dimensions. I'll show you guys that later. So now I'm going to go over the basic features that exist in SolidWorks. Are there any questions so far? I don't know how I went too fast for anyone. Okay, cool, no questions. So I'm going to delete that first sketch that we made. I'm going to orbit, so I am, actually this orientation is weird, so I can hit spacebar and click on the diametric orientation. And now I can see my planes again. So yeah, I'm going to show you the basic features. So in this features tab, you see that there's Extruded Boss Base. You can see in the little animation there, you're basically taking a sketch and then extending it into 3D. With a Revolved Boss Base, you are taking a sketch and revolving it in 3D about a certain axis. Oh, it's telling me to save my part. I ignore that. But don't ignore it. If that pops up every 20 minutes, so if you haven't saved your part in 20 minutes, that means you're not saving enough. So I'm going to show you the first one, the Extruded Boss / Base, which is pretty easy. So I'm going to start a sketch by clicking Sketch, and I'll click on the top plane. This is in a weird orientation, so I'm going to control middle mouse button to pan myself into a better view. Might zoom out a little bit. I'm going to draw a circle, nice and simple. I'm going to let it snap to the origin, which makes a coincident relation, and then click to define the circumference, or a point on the circumference. I'm going to smart dimension. I don't have to tell it where the origin is of the circle, the center point of the circle, because it already gave me that relation. I'm going to click on the circle and give it a diameter. Let's say 50 millimeters. If you notice, it like rescaled everything because this is the only sketch that I have on my part, and this is the first dimension of the part really, since I deleted everything else. So I'm still dimensioning, so I'm going to hit escape, and now I have the circle. I'm going to get rid of the planes because they are kind of annoying. So I have the circle, right? And say I want to make a cylinder, right? If like the 2D flattened version of a cylinder is a circle. So I've made this sketch. I'm going to exit out of the sketch, and I'm going to orbit and look at this circle. So I want that to be extended into 3D. In SolidWorks, you make an extrusion. So I'm going to click on this first feature. So in yellow, it tells you what it wants. It wants a plane on which to sketch the feature cross-section, or an existing sketch. So it could, if you haven't drawn a sketch, you're going to click a plane and then start drawing a sketch. Or if you've already drawn a sketch, you're just going to click it, which I already have. So I can click it in the graphics, or I can actually click it at the top left here. So at this drop down, it'll give me my design tree, and this is really useful if you ever need to, if you're working on something and you quickly need to select a different sketch or a different plane or something, you can pull that down from here. So I'm going to click on this sketch, sketch 3. So now it starts the extrusion process from, you can leave that alone, the direction 1. So I can flip this. I'll zoom in a bit more. So I can flip the direction if it was extruding in the wrong direction. If you notice, it says blind. So this defines the end condition. Blind means it'll go whatever distance you specify here. Let's say that's 50. Let me zoom out a little bit. So I just told this to extrude 50 millimeters in that direction. I can change this from blind to up to vertex, up to surface, offset from surface, up to body. You can play around with those on your own time, but this only really works when there's other things in your part. So if I wanted to extrude this up to the vertex of some corner in the part, I could let it do that. You can also do mid-plane, which is useful. It'll do 50 millimeters, but half on each direction of the center. These other tools, like direction 2 I can talk about, that just says in the opposite direction what kind of extrusion to do if you want. So you could do that. You can also drag these arrows to kind of get a rough sizing. But you're going to want to put an actual number in the left, so that way this is the same as dimensioning it if you put the number in the left. So I'm going to uncheck direction 2 and just have it going in a single direction. Thin feature, is a more complicated aspect of these features. I can go over it in another tutorial or at the end. You can also look into that yourselves. So that's it. So you make a sketch, and then you click on the feature you want. So that's a pretty simple example of an extrusion. And with each feature, there's also the cut version of the feature. So say I wanted a hole cut through the center of this, I would do that by making an extruded cut. So if I click on that, it asks me to pick a sketch or a plane to start a sketch. And I don't have a sketch to choose from, so I'm gonna start a new sketch. So I can do that by clicking top plane in my design tree, which you get by clicking the drop down. Or I can actually just look at the bottom and then click on that flat face. So I'm gonna put a circle down there and draw it like that. Pretty useful. You can actually click one circle and then control click another circle, and that'll let you do a thickness dimension. So let's say I'm gonna make that 5 millimeters. Okay, so still dimensioning. I'm gonna hit escape. I'm gonna exit this sketch that was prompted by the cut extrude feature. So now that I exited the sketch, it's gonna start the cut extrude. So I can do blind. If you're cutting completely through a part, it's actually really smart to tell it to do through all. So this means that no matter what size I made that original feature, this through all cut will cut through it no matter how long it is. You can also flip side to cut, so that's pretty interesting. This will make it cut the outside. I'm gonna show you guys. So I cut the outside. I can double click on cut extrude. No, I can't. I'm gonna right click on it and click edit feature. I didn't want it to cut the outside of that sketch. I want it to cut the inside, so I'm gonna uncheck flip side. If I click the check mark, notice I cut through it. So that's how you do a cut extrude. It's the same thing as a boss extrude, but it's the negative. In some CAD programs, you can actually do that in the same tool, but SolidWorks separates them. For those of you who have done CAD before, you probably have realized that that's kind of an unnecessary way to make this part. I could have actually done it all in one feature. So I'm going to delete that cut extrude. So I just hit delete on my keyboard, and this window pops up and it says delete the following item, cut extrude. That's what I want to do. And then all dependent items. So if I had things that were dependent on this cut, they would be listed here. What that means, I'm going to show by trying to delete the boss extrude. Oh, never mind. Ignore what I just said. So I'm going to delete this, and it's going to hit yes. So now that's gone. If you notice that when I deleted it, it left that sketch that I made. So that's important to know. If you want to sketch back, then you can do that. I'm going to undo that and also show you that in that cut extrude, if I click on the drop down, I have my sketch in here. I can also use that sketch. I can click on it and then make another extrude from that sketch. So you can reuse sketches that were used in a feature. So that's important to know. So I'm going to get rid of that by deleting it. I'm also going to delete that sketch. So say I wanted to make a hole in my cylinder. I can actually do that more simply by opening that original sketch. And then, oh sorry, I'm going to explain what I just did. So I open the drop down and I right click on the sketch and I click edit sketch. You can also right click on the feature and click edit sketch. So be aware that clicking edit feature will not edit anything related to the sketch. It'll just do stuff related to that feature. So this boss extrude won't let me change the diameter. Well, actually, I think I can double click. Oh, I can't see. Yeah, so if you click on edit feature, you're editing that feature, but you're not editing the underlying sketch. So you're going to click Edit Sketch. Now I'm in that sketch. It shows me a preview of what that looks like. It's actually kind of useful if I delete this. If I delete this dimension by clicking on the dimension line and deleting it. Oh, I thought it was showing me the preview. Anyway, so I've got this circle, right? I want a hole in the middle. I can actually just do that in this drawing, right? I can make a circle, do that thickness dimension that I wanted, make that 5 again, 5 millimeters, and then exit the sketch, and it'll update it with having a hole inside of it. So you can do that all at once. So I could draw a plate, right, and I could have the cutouts for accessing buttons or switches. I could have that all in one drawing. I'm just going to show that really quick. So say I have maybe a corner rectangle. If I have this plate, right, and I need instrument access panels, right, I need to access into certain parts of it. I can do a bunch of access features. I can draw like a weird one if it needs to like let through some weird shape. Right, so I drew this. I can exit this sketch and create the feature, but I can also make the feature directly from the sketch by just going to that tab and hitting Extrude. So I'm going to make this 2 millimeters, hit enter, and now I made this plate with all these cuts in it without having to individually make a bunch of cuts. It's up to you if you want to do these things separately. It can be useful to have them as separate items in your design tree, especially if it's complicated. It really depends on the context. If you notice, this is underdefined, right, because I didn't give it any dimensions. It has some relations that are automatically generated when they snapped, when they let it snap to the horizontal and vertical. But if I were actually making a part like this, I would need to define, right, like how far this edge is from here, and the diameters of all these circles and their positions, etc. So I'm going to get rid of that and delete that. And delete it again. So this cylinder, I can actually make the exact same thing using a completely different feature. So I'm going to delete it and delete the sketch. So now I'm going to do a revolve. So in Extrude, you take a sketch and you extend it in one direction, but a revolve, you extend it along or about an axis. So I'm going to show that. So I'm going to make the same part. I'm going to orbit a little bit so I can see the front plane. I'm going to click the front plane. So I clicked Revolve. I clicked Revolved Boss. It's asking me to click a plane to draw a sketch. I could have also already drawn a sketch and just clicked that. Then I click the front plane. It orients me to the front plane. So I'm going to draw a center line first. That's a really good practice. If you're doing a symmetrical part or a revolved part of any kind, is to draw a center line. So you're going to click on the drop down by line and do center line. Alright, and hit escape to stop drawing the line. So now I have this line. I'm going to draw a corner rectangle. So I click to define each corner. I'm going to say that my outside diameter. So remember, in engineering, you tend to not use radii because they're not really measurable. You do diameters. So I'm going to click on the outside line, and then I'm going to click on that center line. You notice that's a radius, right? If that's the cross section of the part. Solidworks is really cool because since I drew a center line and I'm dimensioning to the center line, I can just move my cursor, and now I get a diameter. So you can do that with any type of sketch element. So I could draw a center line and a point, or a center line and a line, a center line and a circle, and you can always, if you're dimensioning to that center line, you can dimension the equivalent radius. So you don't have to do like 2 times some number. This is better, so that way you don't have to worry about math. So that's how a lot of mistakes happen. So I'm just gonna I'll show that again. I drew that center line. I hit escape to get rid of that. I do the center line, smart dimension, click on the center line and then the line. Gives me the radius. I can just move over and I get this diameter. So I think we had 50 millimeters, I think. I'm still dimensioning, but that's good because I want to dimension this thickness. I'm just going to click on the line. Whoops. So I already had that center line dimension, and I clicked on this line, and now since I clicked on two lines, it's trying to give me an angle. I don't want that. So I'm going to hit escape, and I'm going to, oh, look at that. It unselected that first one, so that's good. So it's a good idea to just hit escape between dimensioning because you may accidentally start doing things. I'm going to show you why that happened. Right, so I made this dimension. So 50. And then I went to measure this. And because I didn't hit escape between that action, now it's selecting that previous thing that I had. Anyway, hit escape, and now we are doing that thickness, 5 millimeters. I don't remember how tall we made it, so I'm just going to make it 50. So this center line, if you notice, has an underdefined point on it. That is fine. The center line isn't actually part of the sketch. It's called a construction line. It's like a construction feature. So I can actually draw any type of shape, like say this circle. And if I just needed it to help align stuff, I can just click on the circle and click for construction. So now this circle isn't actually affecting the part, but I can use it to orient things. Like you could, like say that there's a circular feature in this part, and it has some size of 30 or whatever, and it's like 70 millimeters from the bottom. I could just sketch that in as a construction line, and that'll help me when I'm catting up the rest of the part to see, okay, I have to make sure that I'm not hitting this circular feature, right? I could, let's get rid of this 50, for example. Say I wanted to make this as tall as possible, but at minimum a certain distance from that center of that circle. I could say this is like 25, right? So I can use these construction lines, these things that aren't actually real in the part, to define this clearance, for example. Don't know if that helped explain or made it more confusing. I'm going to delete those things. I'm going to delete this dimension because, again, since it's a construction line, it doesn't actually matter. If you're using a construction sketch for something that has a real life dimension, then you're going to put dimensions, but this is just a center line, doesn't matter how long it is. If I look at the part, right, it's still underdefined. I can see that in my design tree. The bottom is underdefined and the top is underdefined. I can't move it left and right because I already told it the diameter and the thickness. Also, when I say diameter and thickness, that's just what it happens to be for this part. SolidWorks doesn't care that this is the thickness, right? This could be any type of length measurement. So I could say that the distance between this line and the origin is 0, or I could click on that bottom and then click on the origin, and I could say coincident. So that would make you think that it would move it to the origin. But coincident, when you're doing with points and lines, it can actually just mean that it'll fix that last degree of freedom. So, right, this can only move up and down. If I say that this is coincident with this, it'll just make it in line with that. So now that's fixed, so that's good. And I'm going to say that this is 50 tall, because I deleted that. So now it's fully defined, which is perfect. And I'm going to exit this sketch. And since I created it in the Revolve feature, it's starting this Revolve process. It's asking me what my axis of revolution is. I already drew one, so it by default selects that. But if this were empty, I would have to select an axis of revolution, right? So if I select this, it'll revolve at about that. If I select this, it'll do it there, here, at the bottom. So you have to be very particular about what you pick. So I'm going to pick the center line. So this is similar to the extrude, right? I can do blind, or up to a vertex, right? I can have it rotate until a certain point. I can also tell it an angle. I can tell it to only give me a 45-degree slice of it. I'm going to do the whole thing. And then I'm going to hit OK. And if you look, I actually ended up making the exact same part. So that's something that you should keep in mind. There's never one correct way to design a part. It just depends on, you know, your kind of style of CADing. I tend to use a lot of revolves. It can depend on like the other things that you're gonna make. So let's edit the sketch that this was made from, and it's at a weird orientation. So I'm gonna hit the spacebar and then give me this nice normal orientation. Say that this had like a round feature, so I just clicked a circle. I'm going to trim away these lines that I don't need. I'm going to tell it that the middle of that circle is 10 millimeters from the top, and that it has a radius of 5 millimeters. So complete circles will be given in diameter, and then sections of circles, like arcs, will be given in radius, because a section of a circle, you can't necessarily measure the two sides of it. Like, what if it's just a portion of a circle, or like a fillet? So you'd have to give the radius. There's really no other way. Anyway, so now this is fully defined again, and if I look, I made this part. Making this with an extrude is basically impossible. So it depends on the type of part. So this revolve is useful for things that are obviously revolved, or shapes of revolution. The Revolved Cut is also, it's the same as a Revolved Boss, but a cut. You can also, in SolidWorks, at the top, if you click section view, you can actually see your part as a section view. In the left, there, your section, you can tell it what plane to cut from, and then you can tell it in these fields, you can tell it the position of this cut plane, or you can move it around yourself and orient it however you want to look at it. So I'm just going to click front plane again. So now we can see that that's what that looks like. So this didn't cut anything. I'm just looking at a section view by using that tool at the top. I'm going to show a revolved cut really quickly. I'm going to click on the front plane. So when you click on a plane or any flat surface, really, you can right click on it and select sketch, so you can actually directly sketch off of that that flat surface. You can also right click on a surface and hover over this normal to icon. This is really useful. If you click on normal to, it'll orient you pointing directly orthogonally to that face. So say you have a part that has like a weirdly angled flat portion, but you want to sketch on it, you can click normal to, and that'll orient you to it, and you can start your sketch. So I'm going to start sketching on the front plane to show you the revolved cut. So I don't know what I'm going to draw. I'm going to draw put a circle here. So I'm going to use a relation to align that circle. I'm going to click on the circle and then click on that curve. Click on the circle. It's bullying me. Hold on, I'm going to get rid of the cross-section view. That usually messes you up. Cross-section is really good for looking at the part, but it's hard to, sometimes it doesn't let you dimension off of things in the cross-section. So I'm going to start that front plane sketch again. I'm going to hit space and then orient myself to the front. I'm going to draw a circle, and if you notice, if I hover over this circle, it'll let me snap 2 points on the circle at 90 degrees. It'll also let me snap to the center, which is super useful for aligning things properly. I'm going to draw that circle. If you noticed when I was doing that, I'll do it again. I'm hovering over the circle and then over the center. It's a white coincident relation icon, which means that when I make the circle, it won't actually be coincident. It's just helping me line it up. So I can click on my circle, I can click on that curve, and I can click on the concentric relation, and that'll force the centers of the two circles to be at the same point. I'm going to give that a diameter, I don't know, 7.5. I'm not really making a real part, I'm just showing the features. Let's say I want to cut like a circular cutout from this. Orient again. I'm going to use a square, a rectangle. So I clicked on that corner of the circle, the top of the circle, and it snapped to that. I'm going to make it snap to the circle again by clicking the coincident, so that point and the circle will be coincident. I'm going to make this line touch the inside surface. So I click on the line, I click on the inside surface. Psych, I can't actually do that, but that's fine. I'm just going to put that at the center of my part. So I'm going to control click the origin and click coincident. I'm sure you've noticed sometimes I'll try to do something and then realize I can't do it. And that's what ends up happening when you do CAD. You learn how to just go with the flow, I guess. So I noticed that this was blue, right? And now that I'm dragging it around, I'm getting this weird like whistle shape. I don't want that. So I'm noticing that this circle and this line aren't actually tangent to each other. So I'm pretty sure if I just, oops, I tell them, control click to be tangent, it'll fix that for me. And there we go. Now it's fully defined. I'm going to give it a center line so it already has an axis to revolve about. So I'm going to start my cut revolve. Oh, apparently not. So I made my sketch. I'm going to click on Revolved Cut, and it by default selected my center line because I already drew it. If it didn't select it by default, you could just click on that. We do a blind 360, and now I have this cut. We do the cross-section view at the top so we can look at it, and now I've got this part with this weird cut in it. Again, some of you may notice that I could have made this all in one feature, right? I could have drawn that U cut out of it. Yeah, so that's the basics of features in SolidWorks, right? There's your Extruded Boss, your Revolved Boss, and then the cut equivalents of those. And then if you make a part or feature and say I click on it, you can actually sometimes have the dimensions that you've made pop up. Depends. It literally just depends on when you. I'm gonna go into that sketch and edit the sketch. It depends on where you physically put that dimension, right? If I put it nice and close, then I can see it. But if I put it way out here, I wouldn't. I'm just gonna exit the sketch. When you click in your graphics window, if you click on features, you are often able to just edit the dimensions by double clicking right in the graphics window, which is super useful. I can change that to 5 millimeters, and then I'm going to hit escape. And you notice I changed it, but it looks like nothing happened, and that's because nothing did happen. If I go in my design tree, you'll see this little, probably can't make it out, but there's a little traffic light icon on my part in the design tree, and there's also on this feature. So if there's one on the part, that means something in the part has this issue, and it tells me that it's this feature and this sketch. So this means that the part has yet to be rebuilt, and rebuilding is the part's like graphical display updating in the software. So I changed this sketch, right? And it didn't automatically update. So I can tell it to update by going to the top of my window and hitting the rebuild icon, which is a little traffic light. You can also do Control B. So once I rebuild it, I see that change take place. So if you ever like edit a dimension or change something in a sketch or edit something, and you don't actually see it show up, you can rebuild with the traffic light icon, and that'll update the graphics. But you should see it in the left, showing you that it's not rebuilt yet. Yeah, that's actually it for most of the stuff that I wanted to talk about. I think I'll just do a little demonstration part if you guys want to follow along. Are there any questions at this point that I can answer? And if any of you guys have been messing around with SolidWorks and come across some type of issue or something you couldn't figure out, you can let me know that now or after the meeting, or after the tutorial, or you can send me a message or whatever. I can try to help you figure that out. Okay, sounds like no questions. Actually, I do want to cover one more feature. This one is extremely useful. I use it all the time. So if you think about it, when you make if you have a part that needs a bolt hole, I'm going to delete this because this is kind of a weird part to look at. Let's undo so you can see what I just did. So I clicked on Revolve, right? That first thing that I made. So this is before the cut happened. I right-clicked it and I deleted it, and then I clicked yes. So it's telling me that sketch 8, so that sketch in the cut revolve, has a warning. It may cause things to fail. If I just continue that, I get all these errors, and it's basically telling me, I'm going to open the sketch. It's telling me, you see these like yellowed out relations, and this can happen to dimensions too. It's yellowed out because the thing that it's referencing, if you remember this circle, I told it to be concentric at the same center point location as that weird outside curve that I gave it. I told it to be concentric. That curve doesn't exist anymore. So now SolidWorks is like, I don't know what to do. You're referencing something that doesn't exist. So I have to either bring back that feature that it's trying to reference, or delete this and redefine it. But it doesn't matter for me because I'm literally just trying to get rid of it completely. So I'm just going to delete it. And if you notice that that cut didn't actually show up in the graphics, because it can't show up because you can't cut away from nothing. Well, you can, but you just won't see anything. I'm going to delete that. It still has a sketch that still has that issue. I'm going to delete it because I don't care. Delete that as well. Best practice is to just start a new part, but I don't feel like doing that. So if you want to follow along, that would be great. I'm going to make a little demo of a nose cone. I'm going to open up this little drawing that I made. Yeah, I think you guys can see that. Oops. So let's pull up the Wikipedia page of it. But one of the nose cone geometries that we can use is called an ogive. I heard it said as ogive and ogive. Like senior engineers that I know say ogive, so I'm just going to say that. But it's a type of nose cone shape that you can use. I didn't want to make a slide, so here's Wikipedia. You can have a nose cone shaped as like an elliptical shape. You can have a cone. Cone is obviously the simplest. You can blunt that cone by having a sphere on the end. You can have a biconic, which means two cones. So it's actually a frustum technically. But anyway, two conic shapes. And then you've got something called an ogive, which is a section of a circle. And this is actually pretty ideal for certain flight regimes. So for certain speeds, this shape is actually optimal. But there's more complicated shapes like parabolic or power series. It's like an x, like a square root shape, or different power series, like x to the number. But just for this tutorial, I'm going to go with a normal tangent ogive. So it's a section of a circle where you take, I do the whole circle poorly here, with some radius rho, Greek letter for r, a circle with some radius. If I cut a section out of it horizontally and use this line, I can have this shape which is called a tangent ogive, where this length of the half cone shape is the length and the radius is here. So this is just an example, right? If I came up with some like radius and length that were optimal to reduce drag and minimize weight and maximize strength, and a thickness of a shell to maximize the strength, I could come up with some sketch like this. So in general, when I ask you guys to come up with sketches from calculations, this is what I'd want. When I ask for sketches of just like a concept, you don't have to put dimensions. So an interesting thing about sketches and yeah, this is a sketch. As long as you put dimensions, you don't have to make it to scale. If you're making an engineering drawing, it has to be to scale, but you usually do that on the computer, so you don't have to worry. But if you look at this part, right, this 155 is almost the same length as this 300, which is basically the same length as 40, and 3.5 does not look the right size. But it doesn't matter, I put my dimensions, so I know what shape this has to be. I also should have written that this curve is a tangent. But yeah, so I'm going to make this in SolidWorks, and if you guys open up SolidWorks, you can follow along. If you have any questions at any point, let me know. This should be pretty simple. Can anyone in the stream tell me what type of feature I would use to make this? No takers? So looking at something like this, you couldn't really make it as an extrude. Like in real life, it would be like this curve shape, right? This is a cross section, so I just sliced it in the middle. You can't really make that with an extrude. I'm sure someone could, but the most practical way is to use a revolve. So I'm actually just going to draw the center line, and I'm going to draw these lines on the right side, and I'm just going to revolve it, and it'll be pretty simple. So yeah, in general, you can really break down any single part in the world as just a series of extrusions and revolves, and the more complicated features like sweeps and lofts and using surfaces and stuff. But in general, when you make a part, you kind of think about how you would break it down into the more simple features. I'm going to put SolidWorks on the side here. It wants to cooperate. Okay, so I'm going to start a sketch on the front plane. So it doesn't really matter what planes you choose to draw stuff on, but for me, I like to pick planes that kind of intuitively make sense, right? So the top plane points upwards, obviously. So I'm just gonna sketch the cross section of this nose cone as if it's sitting on its circular opening and pointing upward. So that would be easiest on the front or the right plane. Just pick the front. So I'm going to hide these sketches because they're in my way. I'm going to draw a center line first. So I'm going to center line. If I hover near the origin, I'll get that yellow permanent coincident relation pop up. I'm going to draw my center line and move it to the middle until it snaps to give me a vertical. relation, and I'm going to hit escape to stop drawing the stop drawing center lines. So if we look back at this diagram, it seems like the best way to start is with some type of circle, right? Because this is all based off of a circle. So what I'm going to do is I'm going to draw a circle. Let's stick a circle somewhere, right? So this circle will not be part of my actual part. So I'm going to click on the circle and I'm going to do for construction because I really just want it kind of like this circle to give me the whereabouts of all the lines. So if we look at this center line, I'm wondering if I want to rotate the screen. That might be useful. I remember how to do that. Okay, if you do Alt and the arrow keys, you can rotate the screen front back. So I'm going to Control, middle mouse click, and pan over. So I'm going to basically recreate that that drawing, that little sketch. Move this line over a bit so it looks a bit more similar. So if we notice, this line comes down from the top point on the circle. So if I click on my circle and I try to start drawing a line and I hover over it, it'll let me snap to this top point. So I'm going to draw a line like that. I'm going to make that a construction line. And if we notice, we basically already just made the shape that we want. So I'm going to look at my little sketch down here, and I can see that my radius is half of 155. I don't want to actually divide by half, so I'm just going to dimension that. Click on this point right in there. And since I use the center line, it lets me do diameter, nice and easy. I'll just click to start inputting the number. 155, hit enter. And remember, I deleted all my sketches and parts, right? So it scaled this whole sketch to that 155 dimension. So that's good. I'm going to hit escape once to unselect the things that I had selected. If we notice, now we're not oriented in the right direction, so it's a little confusing. I'm going to hit Alt and then arrow keys left and right to reorient. Control middle mouse button, drag to pan over. So now I'm going to try to give the dimension from here to this line. And if you noticed, I can't actually click on anything in there because these are just lines. So you can use a point, and it's pretty useful to just stick points everywhere, and they won't actually affect the feature that you make, but you can use them to align things. So I'm going to click on point right there, then hover over until it doesn't quite want to let me auto select both of them. So I'm just going to click on the circle here, escape to stop drawing points. So now this circle is forced to be coincident with, this point is coincident with this circle. So I'm going to click on the point and then click on this line, control click, coincident. Now that point is coincident with both of them. So basically I just made a point where I can dimension from here to this line to get that height, that L dimension of my nose cone. So I'm going to click on that point, click on this guy, and then click to start putting the number, 300 millimeters. That like messed up my whole thing, but that is okay. So what I want is I kind of want to scoot this up so it's all above the origin. I think I can just, looks like I can just drag that up. And I'm going to extend this line so it looks a bit better. So now I've got this huge circle, and I need to actually start putting in real lines for this nose cone. So I'm going to use a tool called the center point arc. So now I can draw a section of the circle. You can also draw a section of the circle by drawing a circle and then using the trim tool, but I think this center point arc is going to be useful here. Remember, there's always multiple ways to do the same thing. So you can do it by clicking a center point, a point on the radius, and another point. You can also do 2 points. I'm going to do that one. I think that'll work. Click on this first point. Okay, didn't like that, so I'm not going to do that. I can do this other way where you define 3 points on the curve. That sounds pretty easy to do here, so click on my first point, click on my second point, and then click on the third point, which is on the arc. I'm going to hit escape to stop drawing arcs. Hit escape to unselect it. If you notice, I've got this nice blue line here, which selects into orange. So that is that first curve that we want. I'm going to draw that shoulder portion here, that straight section, with a line. I'm going to click on that corner, and I'm going to put it down here. So I get the vertical relation is going to be permanent in yellow. The horizontal relation is going to be temporary in white. So if I click down there, escape, I'm going to have this point free to move around. So I'm going to click it, click the origin, force them to be horizontal. If we notice, this can still move up and down, right? So I need to put in that shoulder dimension. Click the line, 40 millimeters. So yeah, you can see this diagram is awful, and I drew it, so I can say that. And it's very much not to scale. But as long as you follow the dimensions, you'll get what the designer originally intended. So if you notice, I need this inner surface, right? So that might be a little tricky. So I'm going to get a line. So I can dimension all these things later. So I'm going to just, it's not going to be to scale. Whoops. So it's telling me I'm going to have a tangent relation. That doesn't sound right. So I'm going to zoom in a bit closer to make sure I'm selecting the right thing. Click on this point, zoom out. See, now there's no tangent relation prompt anymore, so that's good. I've got my horizontal and my coincident, so coincident to this line. Perfect. Up. And then it's going to be coincident with that horizontal construction line, which sounds good. I'm going to hit escape because the rest of it's going to be curved. I'm going to do that by doing I could do another center point, but I think a circle and trimming it might be easier. So I'm going to click on that center. So this is going to have the same center point as that outside curve, which is what I want. I'm going to tell this to be here. I've got this huge circle.
Hey,
yeah?
Rez, quick question.
Sure.
Why don't you do like an offset entities like that button up top?
That can also work. Yeah, like I mentioned, there's always multiple ways. I'm going to finish this, and then I'll do offset so you can see what that looks like.
Okay, yeah, I was just wondering, because that's what
Yeah. So
yeah,
I could do offset entities.
Yeah.
I can actually do something called a shell. So I can just make a solid cone, and then as a separate feature, just cut away all the material inside. I might show that after as well, because that's actually a better way.
Oh, okay. Yeah.
But yeah, that's a good question. Why didn't I use offset? Because I didn't. It really depends on how you CAD, right?
Okay, that's fair. That's fair.
Yeah,
Just
you'll
wondering.
end up with the same part. So yeah, I was just showing this so we're using the same things that we talked about. I'm gonna trim away the circle. So I click the Trim Entities button, and I'm going to drag and trim, but I'm making sure not to hit that outside circle. Looks like that's exactly what we wanted. Looks like there's no circle hanging off here. Looks like it just takes one more line to finish this up. So if you notice, this is like, there's no shading in here. And when I close this, you see how there's, it's like a shaded region. When you do an extrude or a revolve or any type of feature, you need to use closed surfaces. So if I were to just stick a line through this randomly, this is not a closed surface, right? because this is a line that is going to be read by the software, but it doesn't actually make a shape that it can revolve or make a shape that it could extrude. It's just a random line. So you need to have closed curves. So that's open. If I like that, now it's closed. So I'm going to revolve that. Actually, I shouldn't revolve that yet, because if you notice, this is blue, and blue means bad. Blue tells me that it's underdefined. So if I look at my drawing, I still need that thickness. So I'm going to click on the left side and the right side of the shoulder. I could have just clicked on the bottom line. It's always multiple ways. Maybe 3.5, and now that is done. My sketch is basically done. I'm going to revolve this. Ask me what axis I want, so I already made that center line here. Click that, click green checkmark OK, and now, oh, so the cross section view on. I have a little nose cone. I'm gonna go back to my sketch. Hit space to reorient myself with that cube. I'm gonna do what Phil suggested. I'm gonna use the offset tool. So I'm gonna delete that bottom line I made. I'm gonna delete all those inner features. This item has associated dimensions. I don't care. I'm gonna delete it anyway. I'm gonna delete that top segment. So Phil suggested using the offset entities tool. So this tool is really useful. I'm going to click on the things that I want to offset. So click on that first curve, that tangent ogive curve, and click on this straight section. And then at the top, to the right of the trim tool, is the offset entities tool. You click that, and then what it does is you can see it takes that all those features and will offset them either inside or outside. So if I draw like a square, it can offset those inside, make a smaller square, or offset them outside. So here I would put my thickness of 3.5 millimeters. Enter. So now I offset that. If I look at the bottom, it looks like these are perpendicular, the same length. Just to make sure. Well, I have to put the bottom line anyway. You notice this became horizontal, so that's good. That means that that is horizontal. If I go to the top, this is why I didn't do the offset, because this happens, which is perfectly fine. We can just use the trim tool. So we're going to draw that top segment that we wanted. Escape stop drawing lines. So I clicked at the bottom there, so it should be coincident. I think it is. Anyway, we're gonna trim and just trim off that little bit there, and then it should work just the same. Yep, there we go. I'm actually just gonna show. Yeah, we're not too much over time, but I'm just gonna show one more method, which will introduce another feature. And there is a lot of features in SolidWorks. So I'm going to edit this sketch again. I'm actually gonna get rid of those internal lines, that bottom one, that shoulder, this and that line, and I'm going to make a solid nose cone. So I'm going to go from this top point to here, to here, to, I'm going to zoom in so I click the right thing, to there, hit escape. So I'm going to revolve this solid nose cone, right? So it's solid. If I take a look at its cross section, it's just a solid nose cone. So you can use the shell function, which is up here, the shell feature. There's actually a whole lot of features. If you go to Insert Features, there's a very large amount of them. Like this flex one's pretty cool. You can take the nose cone and you can like I don't remember how to use it. Oh yeah, I can make the nose cone do that. So that's always useful. So there's always a ton of features you can learn about. So you can click in here and just mess around with them, or you can Google them or do all the tutorials. I think they cover everything. Anyway, I'm going to show you the shell feature, which is there. You can also find it in features, insert features, shell. So when you start a feature for the first time, it's going to be a good bet to look through all these boxes and all these options. You can find that by searching in the help. So this, if I hover over it, says faces to remove. So it's asking me what face I want to get rid of during my shell operation. So this will make a shell out of a solid. I'm going to click on the bottom because we don't want that anymore. I'm going to click show preview so I can get an idea of what I'm doing. So if I click shell outward, it'll flip the direction. So it'll make a shell like that. I don't want that because I already defined the outside. So now I want a shell of the inside. And I can set my thickness here, 3.5. Click the check mark. So now I have this shell. So that's 3 different ways of making the same geometry. So there's really no right or wrong way. It really just depends on how you want to go about doing it. Like that offset entities, if you remember, it involved trimming something. This shell one, I'd say is probably the easiest because you don't have to make a bunch of lines. But say I wanted the shoulder to be thicker than the cone part, then the shell function wouldn't actually be useful because this is a constant thickness feature. So I would actually have to do that like we were doing before with that original method I did where I actually go in and draw the inside curve. The offset also wouldn't work for that because it would be a constant thickness. So again, there's multiple ways to do things, and it really just depends on what you're trying to get out of the feature. Some features can't do certain functions, like the shell can't do a varied thickness, unless it can. Oh, look at that, it can. I've never used this before, so I don't know how to, but I'm sure one could figure that out. Yeah, so it's been about, I can't do mental math, 110, like an hour and 50 minutes. I may wrap it up, or I could show you guys one more feature. It's up to you guys. I don't know if this has been too long. No one's objecting, so I'm just going to quickly show one more feature that is extremely useful. Get rid of this thing. Goodbye. Oh, it's still there. Okay, so I'm just going to draw a little plate on the top plane. I'm going to do that with a center rectangle. Center rectangle is a good way to make like a nice square part in the middle. If you remember from grade 2, a square is just a rectangle where all the sides are equal. So I can just click on one side and the next side and tell them to be equal. And now it's a square. Very cool. So I'm going to say that this is like 5 centimeters, and I'm going to extrude it as a little plate that is 2 millimeters thick. So now I've got this plate. So if I want to have a hole in this part, like say I need to bolt something onto it, the best way to do that is to use what SolidWorks calls the hole wizard. If you think about it, a hole is really just a cylindrical cut. Like I could do it with an extruded cut or a revolved cut. But that means I have to go to Google and look up like number 10 hole size clearance 2B. So if I wanted a hole that fit a number 1032 screw, and 1032, like you have quarter 20, right? So that first number is the size of the bolt or the drilled hole, and the second number is how many threads per inch there are. So bigger number means there's more threads, so it's finer threads. So if you go like a ½ inch bolt, 3/4 inch bolt, the smaller you get. If you get lower than quarter, it's actually a number standard. So it's 10, 8, 9, blah blah blah, down to like quintuple 0, which is very very tiny. Anyway, we use like 10 and 6 and sometimes 4. So anyway, if I wanted to have a bolt hole for a number 10 bolt, I would have to pull up a web page like this, or pull up a textbook or a mechanics, like a shop book, and go in here and see, okay, if I want a close fit, I need to make the hole 0.196 inches in diameter, right? And that's a lot of work. And if I wanted to change that in my part, like if I made an extruded cut of a circle with this diameter, and I wanted to change that quickly, I couldn't really do it quickly. I'd have to open up a reference again and find that size. So SolidWorks actually has a built-in feature that will just cut holes for you. You don't have to worry about it. So we're going to click on the hole wizard, and then it's going to load up. So I actually like to click this second tab first, this positions tab. So select the face or hole or slot position. So I'm going to click on this surface, and now I'm ready to draw a sketch. So it automatically, if you notice, starts me drawing a point. It starts drawing a point for me. So that point defines the center point of that hole. I'm going to click here and hit escape. And now I've got this sketch right with this point. And I can dimension where that is from this edge, for example. Let's say it's 10 millimeters from there. And let's say it's 25 or say 20 millimeters from there. You should not be dimensioning things from the center of a plate unless it's a round plate, right? Like if I had a plate where I knew where the center was, which would be a round plate, you would dimension from the center. But if it's a square plate or a plate like a rectangular plate, you're going to dimension from the edges. I'll talk about dimensioning in another tutorial, but dimensioning, the way, like I could obviously dimension from the center and get it in the same spot, right? But when you go to make a part, you need to put your dimensions in places that are realistically measurable and easiest to measure, right? So if I made this plate and I gave it to the shop and I told them, hey Alex, I want this hole to be like 5 centimeters from the center in the x-axis and 10 centimeters from the center in the y-axis, he would get annoyed because he would then have to find the center, right? And depending on how the plate is manufactured, right, that center might be different than where it is in CAD. But if I do it from the edge, it's nice and easy because he can just square up the plate in the equipment for marking it, and he can mark where 20 millimeters is, and he can mark where 10 millimeters is, and he can line up the drill press or the mill with that point that marks that. So it doesn't matter for this, but I'm just letting you guys know. So that's where my point is going to be. So I mark the position of that hole, my hole wizard. Whoops, sorry, I didn't actually finish doing that. I'm good. Okay, so I told it where the position is, and then I'm going to tell it what type of hole I want. So there's all these different hole types you can pick from. You can do a regular hole. You can do a countersunk hole, so it has this this conical cutout. So a lot of like wood screws are that geometry. You can have a counter bore. Okay, well it doesn't work because it's too thick. I'll just make it a smaller. Anyway, there it is. There's counter bore. Number 5. Number 4. So it has a cylindrical cutout instead of a conical cutout. So there's many different types, and what you're really going to be using for the type of like Aerostructures parts is just regular holes, maybe a few countersunk holes, but straight taps are very useful. So what this is it's a hole that has threads in it, right? So you can get a number 1032 screw, and you can say, okay, I want a number 1032 threaded hole here at that certain point, and then you say that in your drawing, the machine shop will tap the hole and put threads in it. So just for sake of example, I'll do a straight tap hole. So you can click on the type here. I'm going to do tapped hole. And then what size? Let's just say 632. So that's a number 6 screw with 32 threads per inch. So there's usually two variants. There's a coarser and a finer. So this is 32, this is 40. Do 632. I'm going to tell it, remember we can do blind, but say this screw is going through the whole thing. I could just give it a big number like 50 millimeters, or I could just tell it to go through all and I don't have to worry about that depth. I could also give it a countersink on the near side. I can give it a countersink on the far side, which is kind of weird to do. Yeah, so number 632, threaded hole. And I click OK. And it's really that easy. So that seemed like a lot of steps, but if you think about it, it's really the same amount of steps as extruding a circle. Except now, since I have that, I can right click edit feature and I can super quickly switch to a different size, like I need a 1/4-20 hole, and I didn't have to go find out exactly what hole size I need. And googling the hole size gives you a point of error, like a place to make an error. So if you get that hole size wrong by even like 0.005 inches, like it might not fit, right? So it's best to use the hole wizard because you don't have to worry about that. I'll just show a normal hole. So this is cool too. You can tell it to use drill sizes, which is a good call. But you can also tell it to use screw clearances, which is even easier. So I can say that it's going to fit a number 10 screw, and I can pick a close clearance, a normal clearance, or a loose clearance. I think you'll also learn about that in first year, but I may explain it later or at another meeting. But I can just pick my clearance and then easily click OK, and I'm done. So yeah, if any, I think non-Aerostructures people will see this, but anyway, if your exec asks you to make a hole in a part that needs to fit some type of screw, it's best to use the hole wizard, which is up in the features. Yeah, I think I'm gonna call it a day. I covered everything that I wanted to cover. Are there any comments or questions that I can get to? Okay. Well, thanks. Oh, Noah's typing. Alright, Noah's good. Alright, well, thanks everyone for coming to this. I'll upload the slides for it, as well as a recording of it in the coming days, and you guys can check that out if you missed something. Also, feel free to shoot me a message or Raph a message. Raph has also had quite a bit of CAD experience. If you have any questions, and we can help you out. Alright, thanks for coming.
Sorry, I just wanted to ask this real quick. Can you show me where, I've been looking, I can't find it. Can you show me where to change your preferences? Because right now I'm in inches and I don't want to change to millimeters.
Oh, sure. So it's right at the bottom right of your screen, and there's a little menu, and you can click millimeters, grams, second from there.
Okay, awesome.
Alrighty.
Thank you.
Yeah, no problem. Okay, cool. Thanks for coming. Oh, he's gone. Nice. I guess I'm gonna stop my recording. Let's hope it worked. Wow, 2 hours. Jeez.